thing when you look at the spinal cord is you want to figure out which side is anterior and which side is posterior.
Do you like this model?
I'll use all of them. So this one is easy because you know the spinous process is posterior and the body is anterior. But if you didn't have the bone around it, the vertebrae around it, then what you do is you look for these grooves here. So the groove that isn't as deep, that's called the posterior median sulcus. And the groove that's deeper is called the anterior median fissure, because fissures are deeper than sulci. So that tells you that this is the anterior side and that's the posterior side. So then right in the middle, that little hole is the central canal where CSF runs through. And then this area in the middle is called the gray horns. And so you have the anterior gray horns, you have the lateral gray horns, and then you have the posterior gray horns. The posterior gray horns is where sensory axons come in synapse in the posterior gray horns. The lateral gray horns is where you find visceral motor neurons. And then the anterior gray horns is where you find somatic motor neurons.
I know that for the practical.
Yeah. And then if you look lateral to the spinal cord, you've got the spinal nerves would be out here. And the spinal nerves are sensory and motor axons. So as you get closer to the spinal cord, those axons split. So sensory axons are going to come in through the spinal nerves and then in through the dorsal or posterior side of the spinal cord through the dorsal root. And then on the anterior side, here you've got the axons of your motor neurons coming out through the ventral roots. And the spinal nerve is a combination of axons from the dorsal root and the ventral root coming together. Right here, this is where your unipolar sensory cell bodies are located. And this is called the dorsal root ganglion. So those unipolar sensory neurons that are bringing sensory information into the spinal cord, their axons are in the dorsal root, and their cell bodies are in the dorsal root ganglion. Then if you look here, you can see the meninges. So closest to the spinal cord, this would be the pia mater. And then this right here would be the arachnoid mater. And then this would be the dura mater. So the space here in between the pia and the arachnoid, this is the subarachnoid space, and this would be where CSF is located. So CSF runs through the central canal and then the subarachnoid space. And then above the dura, this would be the epidural space right here. And then you can also see right here and right here, these are called your denticulate ligaments, which is the pia coming off and then attaching into the bone. That's called the denticulate ligaments. And that's there to keep the spinal cord from moving side to side. So if those weren't there, the spinal cord could just move all around this vertebral foramen. So denticulate ligaments anchor it into place laterally. And that covers your spinal cord. Oh, no, one last thing. Your white columns or your white matter. So these would be your anterior white columns or your anterior funiculi. These would be your posterior white columns or posterior funiculi. And these would be your lateral white columns or lateral funiculi. And in this white area is where you have ascending and descending axons carrying information up or down the spinal cord. Oh, and then the commissures, thank you. So you've got the anterior gray commissure right here, and on the other side of the central canal you have the posterior gray commissure. And this is just an area where if you do have axons that have to send information to the opposite sides of the spinal cord, that's where they would go right there. And these would be small, short axons of interneurons sending information from one side of the spinal cord to the other. So anterior gray commissure, posterior gray commissure.